In this section, we're going to be talking about section 8.1, and it's called the Law of Sines. Now, so far we've talked about the circular functions: sine, cosine, tangent, cosecant, secant, and cotangent. And for everything we've done so far, those work only if the triangle is a right triangle. If we're trying to solve different pieces of a triangle and it's right, we could use, sine, cosine, tangent to solve a problem like this. And remember the way we labeled our triangle. Capital letters represent our angles, lowercase letters represent the sides that are opposite them. We could also use Pythagorean theorem. To solve a right triangle. The problem is these only work for right triangles only. So the question comes up, well, how would you solve a non-right triangle? To solve a non-right triangle, we are going to use what's called the law of sines. And we could use the law of sines in two cases. If we have, let's say, like an angle, and a side. And also if we have maybe like an angle, side, angle. Those are some cases where we could use the law of sines to solve them. Now, if we can't use law of sines, we use what's called the law of cosines. And this would happen if you don't have two angles, but let's say you just have one angle, like a side-side angle, or maybe you have like a side angle side, or maybe you have a side-side-side. So we'll be learning about the law of cosines in another lesson, but today and for this lesson I wanted to focus specifically on the law of sines. So let's get into it. What the law of sines says is that if you have any kind of triangle, this works for right triangles, this works for a non-right triangle. Let's label our triangle A, B, C. The sides opposite those angles get lowercase letters. The law of sines says if you take side A and divide it by the sine of angle A, you get a number. That's the same number you would get if you take side B and divide it by the sine of angle B. Because those numbers are the same, we could cross multiply and solve this proportion, allowing us to find different pieces of our triangle. Also, side C divided by the sine of angle C would be the same number. So let's take a look at an example. Let's take a look maybe if we have two angles in one side. What if we knew that angle A was 28 degrees, angle B was 66 degrees, and side C was 8.2. We'll set this up just like when we were solving right triangles. I'll draw my triangle, ABC, and I'm going to set it up so I know exactly what I need to find. And side C was 8.2. Okay, now all triangles, all the angles add up to be 180. So to get angle C, we could do 180 degrees minus the 28 and the 66. And we would get that angle C is, let's see here, I'll do it on my calculator also, 180 minus 28 and minus 66 gives us 86 degrees. So now we have to find side A and B. We can't just do tangent or cosine or something like that because it's not a right triangle. So we have to use our law of sines. And I'm going to plug in what I know. So I don't know side A, but I know angle A is 28 degrees. I know angle B is 66 degrees. And I know a full fraction for C. Side C is 8.2 and angle C is 86. In order to do law of sines, we need to have a full fraction. So at this point, we could either set this fraction equal to this, cross multiply and get side A, or we could set this fraction equal to this one, cross multiply and get side B. It really doesn't matter, and we're going to have to get the other side anyway. So I'm just going to go ahead and set these equal. I'll cross multiply 8.2 times the sine of 66, and that's going to equal B times the sine of 86. Divide both sides by the sine of 86. And if you type this into your calculator, 8.2 times the sine of 66, and divide that by the sine of 86, I'm getting side B is 7.5. So let's label our triangle. And now we just have to find side A, so we'll do the same process. A over the sine of 28 is equal to, now we have a full fraction with B, but this is rounded. So I wouldn't want to use the fraction where I'm using a rounded number. My answer might not be the most exact. So I'm going to use this C value because none of those answers were rounded, is equal to 8.2 over the sine of 86. And I'll cross multiply just like we did before. 8.2 times the sine of 28 is equal to A times the sine of 86. If we divide both sides by the sine of 86, we get that A would equal 8.2 times the sine of 28, divide that by the sine of 86, and I'm getting side A is 3.9. It's okay if you round these to the tenths position. So that's pretty much how the law of sines works. Let's do one other example, and then we'll get into some special cases using the law of sines. What if I told you one angle and two sides? So what if angle B was 38 degrees, and let's say side B was 6.4, and side C was 5.9. So set everything up here, 38 degrees, B is 6.4, C is 5.9. And can we make a full fraction? The answer is yes, with B's, right? We have 6.4 over the sine of angle B is equal to side C over the sine of angle C. Now we don't know what the angle is, so we'll have to use inverse trig. Cross multiply first. 5.9 times the sine of 38 is equal to 6.4 times the sine of C. Divide both sides by 6.4. And inverse trig is very sensitive. So let's not round yet. I'm going to type in 5.9 times the sine of 38, and I'm going to divide that answer by 6.4. And my calculator is telling me it's 0.5675 whatever. I don't want to round this, but I am going to take the inverse sine of both sides. And that'll just give me angle C. And just on your calculator, hit inverse sine, and then if you hit the second negative button, it takes the inverse sine of the exact number that it just pulled up. I'm getting 34.6 degrees. Well, if this is 34.6 degrees, we could do 180 degrees minus 34.6 minus 38. My calculator's telling me it's 107.4 degrees. Don't worry about drawing your triangles to scale. It really doesn't matter. Really, drawing them is just helping us to be organized. And now let's find side A. So we're looking for side A over the sine of 107.4. And that's going to equal our original fraction that's not rounded, 6.4 over the sine of 38 degrees. So we get 6.4 times the sine of 107.4 is equal to A times the sine of 38 degrees. Let's get A by itself by dividing by the sine of 38. And A will equal 6.4 times the sine of 107.4 divided by the sine of 38. And my calculator is telling me that side A would now be 9.9. So those are the basics for doing the law of sines. A little bit more advanced, and just so I'm complete here, I want to talk about ambiguous cases. So ambiguous cases of the law of sines. Now, ambiguous just means special. So, sometimes with the law of sines, if we have a side, and an angle in that order, then it's possible to have 0, 1, or 2 triangles. Let me show you what I mean. It's possible to have 0 triangles if when you go to draw it, the height is bigger than the right side. We would have no solution there. So we have to talk about how to find the height, and we'll talk about that in a little bit. This would be an example of no solution. An example of one solution would be if the height is equal to the right side when you draw it. This would be an example of one right solution, or one right triangle. It's also possible to get one triangle if when you go to draw it, the height is smaller than the right side, but also the right side is longer than the left. Then we would also get one triangle. And in order to get 2 triangles, what has to happen is it has to be just the right amount. So if the height is smaller than the right side, but if the right side is smaller than the left, then you get 2 triangles. One triangle would look like that blue one, and one triangle would look like this. This side stays the same. This angle would be the same. But instead of drawing this side over here, we could actually draw it so it connects like that. So let's take a look at some examples of ambiguous cases. Let's take a look at this one. Say we know that angle B is equal to 38 degrees, side B is equal to 6.4, and side C is equal to 5.9. The way I'd like you to draw all of these triangles is the same way. Whatever angle you get, I would like you to put it right here. So angle B is 38, side B is 6.4. And the other side, I would like it to be on the left side, 5.9. Now this is an example of having a side, and an angle. Just draw them so the orientation looks like this. Let's figure out the height of this triangle. I'm going to show you where it comes from once, and then I'm going to show you a formula that you could always use. The height would be right here. So if we take the sine of 38 degrees, that would equal the height over 5.9. Or if we cross multiply, the height would equal 5.9 times the sine of 38 degrees. Going forward, whenever you have a triangle where you could draw it where it's a side, and an angle, the height is always going to equal the left side times the sine of the angle. That's how you determine what the height is. So in this case, if we do that, 5.9, I'm going to type this into my calculator, 5.9 times the sine of 38 degrees tells me the height is 3.6. Okay, so now let's look at the examples that we talked about up top, where the height is clearly smaller than the right side, and in this case, the right side is bigger than the left. How many triangles is this going to give us? Where the height is smaller than the right and the right is bigger than the left. Looks like we're just going to get one triangle. So we're going to solve this like we usually do. And I'll show you an example of no triangles, and I'll show you an example of two triangles. So now that we know that there's only going to be one triangle, let's solve for it just like we did in the original problems. B, C, and A. I'll just get organized here. B is 6.4. Angle B is 38 degrees. Side C is 5.9. So now let's get into our law of sines and see if we could figure out the missing pieces. We do have a full fraction. We know 6.4 over the sine of 38, and that's going to equal 5.9 over the sine of C. If you cross multiply 5.9 times the sine of 38 and set that equal to 6.4 times the sine of C, we'll divide both sides by 6.4 to get the sine of C by itself. And we get 5.9 times the sine of 38 divided by 6.4 is equal to 0.567 whatever. Taking the inverse sine of both sides, on your calculator what you would do is you would hit inverse sine and then second negative button to get back the exact answer the calculator just did. And this comes out to 34.6 degrees. Now that we have two angles, we could do 180 minus those angles to get the third one. 180 minus 38 minus 34.6 is 107.4 degrees. And now let's go ahead and find side A. Side A over the sine of 107.4 is equal to, well, I don't want to use C because this was rounded. So let's do side B over the sine of 38 degrees. We'll cross multiply. Divide both sides by the sine of 38. And we get that side A is equal to 6.4 times the sine of 107.4 divided by the sine of 38, and we get 9.9. Okay, so we have one solution. We just figured out exactly what it is, and that's good. So now let's take a look at another example. All right, so in our next example, let's take a look at this, where angle B is equal to 38 degrees, side B is 2.9, and side C is 5.9. We have an angle, so automatically I asked you to please draw it over here on the left side. The side opposite is 2.9, and the other side that we're given, I'd like you to draw it on this side, so we have consistent left and right sides we can reference. The height is always going to equal the left side times the sine of our angle. So the height is going to be 5.9 times the sine of 38 degrees. Typing that into my calculator, 5.9 times the sine of 38 degrees is 3.6. So look at the picture that we have here. If the height is 3.6, well, 2.9 is smaller than that. So if we did draw this to scale, 2.9 would look like that. It's never going to touch. And because, here's my accent, because the height is bigger than the right side, there's no solution. There's nothing else we could do here. Let me just show you what happens. What if you didn't check the height? What if you tried to do this and you tried to get an answer? What would happen? Well, we can make the fraction side B over the sine of angle B is equal to 5.9 over the sine of angle C. Let's see what happens. We'll cross multiply. 5.9 times the sine of 38 is equal to 2.9 times the sine of C. Divide both sides by 2.9. And we'll get that the sine of C is equal to 5.9 times the sine of 38 divided by 2.9. My calculator's telling me it's 1.25. Well, this is a problem because the sine of any angle is only going to be between 1 and -1. Sine graph looks like this, remember. So the question's asking you, what angle gives you a sine of 1.25? Nothing. Say if you didn't even think about this, what if you typed into your calculator inverse sine of that number? My calculator is telling me an error. All this is pointing you to the same answer. There's no possible solution. All right, this takes into account the option I wrote over here, where if the height is bigger than the right side, there is no solution. Let's take a look at one with two triangles. Let me show you what that looks like. What if we had angle B was 38 degrees, side B was 4.7, and side C was 5.9. We'll put our angle in our bottom left corner, and we'll label everything else like I asked you to label. First, let's start off by finding the height. Now, the height would equal the left side times the sine of our angle. So our left side is 5.9. The sine of 38 degrees, let's see what this is. So 5.9 times the sine of 38 is 3.6. The height is 3.6. Okay, so we have our height is smaller than the right side. So fortunately or unfortunately, we have an answer. We have to find it. But we have the right side is smaller than the left. 4.7 is smaller than 5.9. Let's take a look at the options we have here. The right side is smaller than the left, and the height is smaller than the right, so we have two triangles. The second triangle is a little bit tricky to see, but I'll walk you through that. First thing let's do is let's find the normal triangle, and then we'll find the second. So we'll get organized. We'll have A, B, and C. We're going to use law of sines like we usually do. We have a full fraction with B, 4.7 over the sine of 38 is equal to 5.9 over the sine of angle C. So we'll have to cross multiply and change color here. We'll get 5.9 times the sine of 38 is equal to 4.7 times the sine of C. Divide both sides by 4.7. So we'll get the sine of C is equal to 5.9 times the sine of 38 divided by 4.7. Comes out to 0.772 whatever. We want to get C by itself, so let's take the inverse sine of both sides. So on my calculator, I'm going to hit inverse sine, second negative, and I get angle C is 50.6 degrees. So to get angle A, I'm going to do 180 minus 38 and 50.6. And my calculator is telling me angle A is 91.4 degrees. So now we just have to find side A. So I'll write side A over the sine of 91.4 is equal to, I don't want to use this because it's rounded, so let's use the B's, 4.7 over the sine of 38. Cross multiplying, we get 4.7 times the sine of 91.4 is equal to A times the sine of 38. We'll divide both sides by the sine of 38. And we get side A is equal to 4.7 times the sine of 91.4 divided by the sine of 38. Comes out to 7.6. So we have our first triangle. Now let's talk about our second triangle. To get our second triangle, we have to keep this side here. That side's going to stay 5.9. we have to keep this angle 38. That's what the problem told us. Angle B was 38. But 4.7 I could actually draw over here. That green highlighted triangle is going to be our second triangle. This side is going to be 4.7. It's the same side as this, but instead of drawing it out to the right like that, I'm bringing it into the left. That's where our second triangle comes from. So let me draw this out. And we had angle B, C, and A. Angle B we were told were 38. It was 38 degrees. This was 5.9, and this was 4.7. So I'm going to get set up just like we did before. It's a totally different triangle. But even though it's a totally different triangle, we are going to use some components of what we just did. So for example, if you remember back to geometry, if you have two sides equal, like these are the same side, right? Two sides that are equal is called an isosceles triangle. Two sides are equal, their angles are equal. So that angle was 50.6. That's actually the same angle that goes outside right here, which is going to help us when we go to solve our triangle. If that angle is 50.6 degrees, we have a straight angle or a supplementary angle. If that angle is 50.6, angle C, because it forms a straight line, would be 180 minus 50.6. And that comes out to 129.4 degrees. Well, now we have two angles, so let's find angle A, 180 minus the 38 and minus 129.4. Gives us a tiny little angle, 12.6. So now we could use law of sines to finish this. We have a full fraction with the b's. I don't want to use this because it's rounded. So I'll set it up 4.7 over the sine of 38 is equal to side A over the sine of 12.6. Cross multiplying, we get A times the sine of 38 is equal to 4.7 times the sine of 12.6. Let's divide both sides by the sine of 38 to get A by itself. And we'd get side A is equal to 4.7 times the sine of 12.6 divided by the sine of 38 equals 1.7. And that gives you the second triangle. So our answer for this problem, the two triangles, this is one triangle, the normal triangle, but we actually use that to get the second triangle. All right. And then just to finish up this section, it's a little bit longer, but we also have to talk about area of triangles. And luckily, this is pretty easy. The area of triangles, I have three sets of formulas for you. The book only tells you two. I'm going to give you three to make things extra easy. Now, the area of a triangle is equal to 1/2 the base times the height, right? So what if we have a problem like we just did? If we have, say we have an angle here, and we have like a side, I'll label this A, B, C. What if we know side B, angle A, and the base is side C? Well, the height of this triangle is equal to, remember what we said, it's the left side times the sine of the angle. So that's the height. So the area of this triangle would be 1/2 times the base times the height. That's a formula to find the area of a triangle. So I'll break it down for you. If you have a side angle side triangle like this, side angle side, what we could do to find our area is we could just plug into 1/2 b times c times the sine of a. I'm just going to rearrange it so it's in alphabetical order. What if we had angle b instead, and it's side angle side? Well, we could put the angle there and the other two sides would go here. And then if we had, let's say, angle C, we could put the other sides here, and those would be our formulas for a side angle side triangle. Let me show you an example where we could use this formula. What if we knew that angle B was equal to 74.2 degrees, side C was 19.7, and side A was equal to, like, say 27.3. So we have a side angle side. If we were to draw it out, here's angle B, and we would either have side C here or A, or they would be switched. Well, very simply, the area of this triangle, because it's in side angle side form, would be 1/2 of 19.7 times 27.3 times the sine of 74.2 degrees. The formula that we used was this one with angle B in it. And if we type that into the calculator, 0.5 times 19.7 times 27.3 times the sine of 74.2 gives us the area is 258.7, and you just want to make sure you say square units. Whenever we're talking about area, it's always in square units. So that's if we have a side angle side situation. What if we have two angles and a side? Well, if we have two angles, we could always find the third angle. And the area in this case would be 1/2 a squared times the sine of b times the sine of c all over the sine of a. And if you notice, we have this and this, right? So that's how we can get our other formulas. 1/2 of b squared times sine of a times the sine of c all over the sine of b. And our third formula would be 1/2 of c squared times the sine of a times the sine of b all over the sine of c. So you're picking your formula based on what side you're given. Let's say you know that side b is equal to 5.3. You know angle A is 37.4, and you know that side C is equal to, let's say 78.2. So we have two angles and a side. Well, the side is going to determine that we use this formula. So just make sure you type it into your calculator correctly. The area would equal 1/2 of 5.3 squared times the sine of A times the sine of C divided by the sine of B. And we don't know what B is yet, right? We have to figure that out. Well, it's not a big deal. If A is 37.4 and angle C is 78.2, we could do 180 minus those angles, and that would tell us easily what angle B is. So 180 minus 37.4 minus 78.2 gives us angle B, which is 64.4 degrees. So now we just have to make sure we type this into our calculator correctly. I'm going to type it in just like it's here. 0.5 parentheses 5.3 parentheses squared times the sine of 37.4 close parentheses times the sine of 78.2 close parentheses, divide the whole thing by the sine of 64.4. And my calculator's taking a little time to think about this. It's telling me the answer is 9.3 square units. So we have a formula to help us figure out the area of a triangle with one angle. We have one to figure it out if there's two angles. But what if there are no angles? We're going to use something called Heron's formula. And we use this to find the area of a triangle if we're only given three sides and no angles. So Heron's formula says the area of a triangle with three sides is equal to S times S minus A times S minus B times S minus C, all inside of a square root. Now the question is, well, what is S? S is equal to 1/2 of A plus B plus C. So let's take a look at an example. What if I told you side A was 12, side B is 8, and side C was 6? First thing we have to do is figure out what S is. S would be 1/2 of 12 plus 8 plus 6. So 0.5 times 12 plus 8 plus 6 is 13. So then finally, to figure out the area of this triangle, it would be 13 times 13 minus 12 times 13 minus 8 times 13 minus 6. So I'm going to type this into my calculator. Just make sure you're careful with the parentheses on your calculator. I think as soon as you hit the square root button, it opens up a parentheses here. So we're going to do the square root of 13, open up another set of parentheses, 13 minus 12 times 13 minus 8 times 13 minus 6. And my calculator is telling me this is 21.3 square units. So we've talked about a lot in this section. We've talked about how the law of sines works. We've talked about special cases for the law of sines. And then we talked about how to find the area of any kind of triangle. One other thing I just want to point out quickly is you don't have to use a specific formula for the triangle. I mean, say if you were given three sides. In the next section, the law of cosines, we'll talk about how to find angles if we're just given all sides. But say if we had these two formulas. If we were given any one of these, we could always use the law of sines, find the missing pieces, and then pick whatever formula you want. So you have plenty of options, you have plenty of formulas, and I'm confident at this point that you could pick the correct formula for the correct application. Thank you very much for your time. Please stay tuned for the next lesson.